Take a deep breath, feeling the air expand your lungs, and let your body settle into the quiet gravity of the earth beneath you. Release the tension in your shoulders as we begin a journey not into the stars of the galaxy, but into the microscopic cosmos of scent and the profound biology of how we perceive the world. As you lie there, perfectly still, you are constantly interacting with an invisible sea of chemistry. Every breath you take draws in millions of volatile organic compounds, tiny molecular messengers that have the power to alter your brain chemistry in a fraction of a second. This is the science of aromatherapy, a discipline rooted in the complex interplay between the botanical world and the human nervous system. Consider for a moment the sheer sensitivity of your own body. Humans possess roughly 400 different types of functional odorant receptors, located in a small patch of tissue high inside the nasal cavity called the olfactory epithelium. While we often think of our sense of sight as our primary window to the world, your sense of smell is actually 10,000 times more sensitive than your sense of taste, capable of detecting some substances in concentrations of less than 1 part per trillion. This sensitivity exists because of a remarkable biological design. The olfactory bulb, a structure located at the base of the forebrain, is the only part of the human brain that is directly exposed to the external environment, separated only by a thin, porous bone called the cribriform plate. When you inhale the scent of a crushed leaf or a blooming flower, you are inviting the environment to touch your brain directly. Imagine a molecule of linalool, a terpene alcohol found in abundance in lavender. To be detected by your nose, this molecule must be incredibly small and light, typically possessing a molecular weight of less than 300 daltons. If the molecule were any heavier, it would be too dense to float in the air, and it would never reach your senses. Linalool has a molecular weight of approximately 154.25 daltons, making it a perfect traveler through the cool evening air. As this tiny, invisible molecule enters your nostril, it travels at the speed of your breath, about 4 to 5 meters per second, during a relaxed inhalation. It passes through the nasal conchae, bony ridges that swirl the air into a vortex, ensuring the molecules make contact with the olfactory mucus. Within this mucus, the molecule finds its way to a specific receptor, fitting into it like a key into a lock. This lock and key theory, refined by the Nobel Prize-winning research of Linda Buck and Richard Axel in 1991, explains how our 400 receptor types can distinguish between an estimated 1 trillion different scents. When the linalool molecule clicks into place, it triggers a bioelectrical signal. This signal does not travel to the thalamus like sight or sound. Instead, it goes straight to the limbic system, the ancient emotional brain that houses the amygdala and the hippocampus. This direct connection is why a scent can bypass your logical mind and immediately evoke a feeling of peace or a vivid memory of a childhood garden. The amygdala, which processes emotions, and the hippocampus, which handles memory, are physically hardwired to your olfactory pathway. In the quiet of this moment, think of how the scent of rain or old books can pull you through time. This isn't just a poetic coincidence. It is the result of the physical proximity of these brain structures. When you engage with aromatherapy, you are using chemistry to navigate the architecture of your own mind. Let us consider the chemistry of the plants themselves, the master architects of these scents. Essential oils are not actually oils in the traditional sense, but highly concentrated secondary metabolites. It is a testament to the density of nature that it takes approximately 250 pounds of lavender flowers to produce just 1 single pound of pure lavender essential oil. These liquids are composed of hundreds of different chemical constituents, primarily terpenes and terpenoids. Terpenes are the largest and most diverse group of naturally occurring compounds, and they serve as the plant's defense mechanism, its communication system, and its way of interacting with the sun and soil. One of the most profound terpenes found in the forest air is alpha-pinene. If you have ever walked through a grove of pine trees and felt an immediate sense of clarity, you have experienced the physiological effects of this molecule. Alpha-pinene is a bronchodilator, meaning it physically opens the airways in your lungs, allowing for deeper oxygenation. Furthermore, scientific studies have shown that alpha-pinene can inhibit the enzyme acetylcholinesterase in the brain. By slowing the breakdown of the neurotransmitter acetylcholine, this forest-borne molecule helps maintain focus and memory, acting as a gentle bridge between the stillness of the trees and the activity of your neurons. As you continue to breathe, imagine the process of extraction that brings these molecules to us. The most common method, steam distillation, is a dance of temperature and pressure. Water is heated to its boiling point of 212 degrees Fahrenheit, and the resulting steam is passed through the plant material. The heat ruptures the tiny microscopic sacs, the glandular trichomes, that hold the essential oil. The oil then vaporizes, rising with the steam before being cooled back into a liquid state in a condenser. Because essential oils are hydrophobic, they naturally separate from the water, floating on the surface like a concentrated essence of the plant's life force. There is a fascinating concept in aromatherapy known as chirality, or handedness. Many scent molecules exist in two forms that are mirror images of each other, much like your left and right hands. Consider the molecule limonene, which is the primary component of citrus oils. D-limonene, the right-handed version, smells like bright, sharp oranges and is known for its ability to stimulate the production of serotonin, the feel-good hormone. Its mirror image, L-limonene, has a scent closer to pine or turpentine. Though they are made of the exact same atoms, 10 carbons and 16 hydrogens, their three-dimensional shape determines how they interact with your biology. Your nose is so sophisticated that it can distinguish between these mirror images instantly, a feat of molecular recognition that would require advanced laboratory equipment to replicate. In the world of aromatherapy, we often look to the molecule 1,8-cineol, also known as eucalyptol. This compound, found in eucalyptus and rosemary, has been scientifically proven to increase cerebral blood flow when inhaled. In a study published in the journal Natural Product Communications, researchers found that the inhalation of rosemary oil led to a significant increase in the speed and accuracy of mathematical tasks. This happens because 1,8-cineol enters the bloodstream through the nasal mucosa and the lungs, eventually crossing the blood-brain barrier. It is a reminder that the scents we enjoy are not just smells, but active pharmacological agents that gently nudge our physiology toward a desired state. As the air moves slowly in and out of your body, feel the weight of your limbs, knowing that even the temperature of your skin affects how you perceive these scents. Aromatherapy is most effective when the body is in a state of rest, as the parasympathetic nervous system, the rest and digest mode, allows for better absorption and processing of these compounds. When you are relaxed, your heart rate slows and your peripheral blood vessels dilate. This increased circulation helps transport the absorbed molecules from your lungs to your various organs. Consider the molecule cedarwood, found in the wood of cedar trees. Research has demonstrated that inhaling cedarwood can significantly lower heart rate and blood pressure by increasing parasympathetic activity. It acts as a natural sedative, a chemical signal to the body that it is safe to let go of the day's burdens. The scent of wood is the scent of stability, of deep roots and slow growth, and the molecules within that scent are literally whispering to your heart, telling it to beat with a more rhythmic, peaceful cadence. The speed at which this happens is truly breathtaking. A scent can be detected by the human brain in as little as 110 milliseconds, faster than the blink of an eye. This rapid processing is a remnant of our evolutionary past, when the ability to instantly detect the scent of a predator or the smell of smoke was a matter of survival. Today, we use that same lightning-fast pathway to find tranquility. Within seconds of inhaling a calming scent, the brain begins to shift its wave patterns. Lavender, for instance, has been shown to increase the power of alpha and theta brain waves, which are associated with deep relaxation and the bridge between wakefulness and sleep. You may also feel a slight cooling sensation as you breathe. This is often the work of the trigeminal nerve, the fifth cranial nerve, which provides sensory input for much of the face. Certain molecules, like menthol, do not just trigger olfactory receptors. They also activate the TRPM8 ion channels on the trigeminal nerve. These are the same channels that respond to cold temperatures. Even if the air in your room is warm, these molecules can trick your nervous system into feeling a refreshing, icy clarity, a sensory illusion that helps to clear the heat of a busy mind. The beauty of aromatherapy lies in this intersection of the physical and the ethereal. We are dealing with vapor pressure, the tendency of a substance to turn into a gas. High-note oils like bergamot or grapefruit have high vapor pressure and evaporate quickly, in giving us an immediate burst of energy. Base-note oils like sandalwood or patchouli have low vapor pressure. Their heavy, complex molecules linger for hours or even days, providing a grounding foundation for our senses. This slow evaporation is governed by the laws of thermodynamics, yet it feels like a slow, rhythmic song played for our benefit. As you drift closer to the edge of sleep, realize that your body is a sophisticated laboratory, constantly analyzing the invisible world around you. Every inhale brings in a library of information. Every molecule of linalool, pinene, or cedrol is a tiny key, unlocking a specific response within your cells. You are not separate from the chemistry of the earth. You are a part of it, reacting to the botanical world with a precision that has been refined over millions of years of evolution. The science of scent is a science of connection. It is the study of how the essence of a plant, forged in the heart of a forest or a sun-drenched field, can find its way into the deepest centers of the human brain to provide comfort. There is no need for complex math or loud interruptions here. There is only the quiet, steady dance of carbon, hydrogen, and oxygen atoms as they float through the air and settle into the receptors of your mind. In this silent, microscopic world, everything is moving exactly as it should, with the slow, deliberate grace of the universe's clockwork. Your breath is the engine, and the air is the messenger, carrying the wisdom of the earth directly to your spirit. Feel the lightness of being, the weightlessness of the molecules as they drift, and the profound peace of a body in perfect harmony with the air it breathes. The scent molecules we discussed previously have traveled a very long road to reach your awareness tonight. While the biology of your olfactory system is a masterpiece of modern evolution, the human understanding of these volatile messengers stretches back across the millennia, echoing through the halls of ancient civilizations. Picture yourself standing in the Fertile Crescent of Mesopotamia nearly 4,000 years ago. The archaeological record reveals that as early as 1800 BCE, Sumerian scribes were etching formulas onto clay tablets, detailing the use of thyme and myrtle for their healing properties. These tablets represent some of the earliest recorded attempts to categorize the chemical power of the botanical world, acknowledging that certain plants possessed a spirit or essence that could alter the human state. As you breathe in the cool, still air of your room, consider the weight of that history. In ancient Egypt, the relationship with aromatics was even more sophisticated and deeply woven into the fabric of daily life. The Ebers Papyrus, a medical scroll dating back to approximately 1550 BCE, contains over 800 distinct prescriptions and recipes, many of which relied heavily on aromatic resins and oils. One of the most legendary blends from this era was kaifi, a complex incense burned in temples to mark the transition from day to night. Scientists who have analyzed the remnants of these ancient recipes found that kaifi consisted of exactly 16 specific ingredients, including myrrh, cardamom, cassia, and juniper. The Egyptians understood that the rhythmic burning of these resins could induce a state of tranquil contemplation, a proto-science of what we now call the relaxation response. Notice how the narrative of scent is also a narrative of trade and the slow movement of the Earth's resources. By the 1st century CE, the Roman Empire's appetite for aromatics had grown so vast that it shaped the economy of the known world. Records from the historian Pliny the Elder indicate that the Romans were importing an estimated 3,000 tons of frankincense annually from southern Arabia. To put this in perspective, frankincense was so highly prized that it was transported across 1,500 miles of desert by camel caravans, a journey that took months to complete. Pliny also documented the market value of these scents. A single pound of high-quality lavender flowers could sell for up to 100 Roman denarii. At that time, 100 denarii represented the entire monthly wage of a common laborer, making the luxury of a scented bath a testament to the immense value placed on these molecular compounds. In the 4th century BCE, the Greek physician Hippocrates, widely regarded as the father of medicine, moved the study of aromatics into a more clinical light. He believed in the concept of the 4 humors: blood, phlegm, yellow bile, and black bile, and maintained that health was a state of balance between them. Hippocrates was known to prescribe daily aromatic baths and scented massages to his patients, asserting that the way to health is to have an aromatic bath and a scented massage every day. While his understanding of humors has been replaced by modern physiology, his observation that scents could physically alter the body's equilibrium remains a cornerstone of aromatherapy today. What's happening now is a descent into the technical evolution of how we extract these essences. For centuries, the primary method of capturing scent was through enfleurage, pressing flowers into fat, or simple maceration. However, a monumental shift occurred in the 10th century, in the golden age of Islamic science. The Persian physician and polymath Avicenna, also known as Ibn Sina, revolutionized the field by refining the steam distillation process. His breakthrough was the invention of the refrigerated coil, a long, spiraled tube that allowed the steam carrying the essential oil to cool more efficiently. This advancement made it possible to extract pure floral waters and essential oils with a level of concentration and clarity never before seen. Because of Avicenna's refrigerated coil, we were finally able to separate the soul of the plant from its physical form, a process that follows the strict laws of thermodynamics. The history of aromatherapy is not just found in ancient scrolls, but in the sudden moments of scientific discovery. The modern term aromatherapy was actually born out of a laboratory accident in 1910. The French chemist René Maurice Gattefossé was working in his family's perfumery laboratory when an explosion occurred, severely burning his hand. In a moment of reflexive pain, he plunged his hand into the nearest vat of liquid, which happened to be pure lavender essential oil. Gattefossé was astonished to find that his hand healed with remarkable speed and, perhaps more importantly, without the typical scarring or infection associated with such burns. This event led him to dedicate his life to researching the medicinal properties of essential oils. In 1937, he published his landmark book, Aromatherapy, Les huiles essentielles, hormones végétales, which provided the first modern scientific framework for the field. Observe the slow, rhythmic progression of this knowledge as it moved into the mid-20th century. In the 1950s, an Austrian biochemist named Marguerite Maury expanded Gattefossé's work by integrating it into the world of holistic wellness. She is credited with developing the individual prescription, where essential oils are selected based on the specific physical and emotional needs of the person. Maury was one of the first to propose that these oils could cross the skin barrier and enter the bloodstream, a claim that has since been verified by modern pharmacokinetics. Her work focused on the vitality of the oils and their ability to influence the limbic system, long before the functional MRI could map exactly how those pathways functioned. Consider the dedication required to produce these substances throughout history. The scale of botanical production is truly staggering. For example, to produce just 1 single pound of pure rose essential oil, Rosa damascena, it takes approximately 10,000 pounds of rose petals. These petals must be harvested by hand at dawn, when their oil content is at its peak, before the heat of the sun causes the volatile compounds to dissipate into the atmosphere. This high ratio of raw material to finished product explains why, in the Hellenistic period, myrrh was often traded for its equal weight in gold. When you smell a single drop of rose or myrrh, you are experiencing the concentrated effort of thousands of blossoms and the accumulated energy of a full-growing season. The archaeological record also brings us the Edwin Smith papyrus, dated to roughly 1600 BCE. This document is fascinating because it contains the earliest known descriptions of neuroanatomy. Even then, ancient healers were using aromatic resins to treat head wounds and cranial trauma, intuitively understanding that the nose provided a direct gateway to the brain's internal structures. They may not have known about the 400 olfactory receptors we discussed earlier, but they observed the results of their applications with clinical precision. In the 1st century CE, the Greek physician Dioscorides wrote De Materia Medica, a 5-volume encyclopedia that described over 600 plants and their therapeutic uses. This text remained the supreme authority on herbal medicine for over 1,500 years. Dioscorides provided detailed instructions on how to identify plants like lavender and chamomile and how to prepare them to maximize their soothing effects. This consistency of knowledge across centuries shows that the human relationship with these molecules is not a passing trend, but a fundamental part of our biological history. At this very moment, your body is partaking in a tradition that once protected people during some of history's darkest times. During the Black Death in the 14th century, doctors famously wore plague masks with long bird-like beaks. These beaks were stuffed with aromatic herbs such as cloves, cinnamon, and dried roses. While they incorrectly believed these scents would repel miasma or foul air, we now know that many of these plants particularly cloves and cinnamon, contain high levels of phenols like eugenol, which possess potent antibacterial and antiviral properties. A famous legend from 1413 tells of 4 spice merchants, known as the 4 thieves, who used a specific blend of cloves, lemon, and eucalyptus to protect themselves while they robbed the graves of plague victims. Whether the legend is entirely true or not, the thieves' oil blend is still studied today for its powerful antimicrobial effects. In more recent history, the 1970s saw a surge in clinical interest at the University of Milan. Researcher Paolo Rovesti conducted studies demonstrating that citrus oils, specifically bergamot and lemon, could significantly reduce anxiety and depression in patients. He was one of the first to provide measurable data on how these plant vapors could alter human psychology in a clinical setting. His work paved the way for the integrated aromatherapy used in modern hospitals today. As you submerge into the quietude of your surroundings, think of the sandalwood tree, Santalum album. Unlike many plants that can be harvested annually, a sandalwood tree must grow for 30 to 60 years before its heartwood develops a sufficient concentration of alpha-santalol, the primary compound responsible for its sedative effects. This means that the sandalwood scent used in ancient rituals was the result of over half a century of the Earth's slow, patient growth. It is a scent that requires a vast time scale, a reminder that the best things in the universe often take time to settle and mature. The history of aromatherapy is a testament to the enduring power of the molecular world. From the clay tablets of Sumeria to the modern laboratories of Europe, we have spent thousands of years learning to converse with plants through the language of scent. You are a participant in this ancient dialogue. Each breath you take is a connection to the physicians of Egypt, the traders of the Silk Road, and the chemists of the Renaissance. The molecules are the same now as they were then. The physics of their movement has not changed. They still float with the same weightless grace, governed by the same constants of gravity and vapor pressure that have existed since the cooling of the Earth. In this realization, there is a profound sense of continuity and peace. The world is old, the science is deep, and you are here, safe in the flow of time. The movement of these aromatic molecules through the air of your room follows a principle of physics known as Brownian motion. Imagine a crowded ballroom where every person is gently bumping into one another. This is how the nitrogen and oxygen molecules in the air interact with the heavier essence of the plants. Named after the botanist Robert Brown, who first observed this phenomenon in 1827, this random, zigzagging motion ensures that the scent eventually reaches you even in a perfectly still room. What you are experiencing is the silent, kinetic energy of the universe, a microscopic ballet where billions of collisions happen every second, dispersing the botanical messengers until they are evenly distributed through the space around you. Picture this process as a slow-motion rain of microscopic jewels. While a raindrop is visible to the naked eye, a molecule of an essential oil is roughly 1,000 times smaller than a single human skin cell. Because of their incredibly low molecular weight, often under 200 daltons, these compounds do not simply fall to the ground. Instead, they remain suspended, floating like cosmic dust in the solar wind. At this very moment, as you inhale, you are drawing these travelers into the most delicate architecture of your body, the respiratory system. Think of your lungs not as two simple balloons, but as an inverted ancient forest. The trachea is the sturdy trunk, branching into the bronchi, which then divide into smaller bronchioles, like the thinning twigs of a willow tree. At the very tips of these twigs are the alveoli, tiny air sacs that look remarkably like clusters of grapes. There are approximately 300 million to 500 million of these alveoli in your lungs, creating a staggering total surface area of about 70 to 100 square meters. To visualize this, consider that if you were to unfold the inner lining of your lungs, it would cover the entire surface of a professional tennis court. This vast, hidden landscape is designed for one purpose: the efficient exchange of life-giving gases and, in this case, the absorption of therapeutic molecules. The barrier between these air sacs and your bloodstream is known as the alveolar capillary membrane, and it is incredibly thin, measuring only 0.2 to 2.5 micrometers in thickness. For comparison, a single human hair is about 70 micrometers wide. This membrane is so thin that the botanical molecules pass through it almost instantaneously, entering your circulatory system like a soft whisper passing through a silk curtain. Once they cross this threshold, they are no longer just scents. They are active chemical constituents traveling through a river of blood that reaches every corner of your anatomy in about 1 minute. Consider the specific chemistry of lavender, specifically the compound known as linallyl acetate. In high-quality lavandula angustifolia, this ester can make up as much as 35% to 45% of the total oil composition. Esters are a specific class of organic compounds known in chemistry for their profound ability to soothe the central nervous system. When linallyl acetate molecules enter your system, they act like a gentle hand pressing a mute button on a noisy television. They have been shown to interact with the GABA-A receptors in the brain, which are the same receptors targeted by many pharmaceutical sleep aids. However, instead of a heavy artificial suppression, the lavender molecules provide a subtle shift in the electrical polarity of your neurons, encouraging a natural transition into a state of repose. Deep within the chemistry of another flower, the German chamomile, or Matricaria chamomilla, lies a fascinating transformation. During the steam distillation process, a precursor called matricin is converted into a compound called chamazulene. This molecule is not present in the living flower. It is born from the heat and pressure of the still. Chamazulene is famous for its deep ink blue color and its potent anti-inflammatory properties. Scientists have found that alpha-bisabolol, another primary constituent of chamomile, can comprise up to 50% of its essential oil. This compound serves as a biological signal that inhibits the production of pro-inflammatory cytokines, much like how a calm voice can de-escalate a tense situation. As you breathe in the essence of chamomile, imagine this blue warmth spreading through your tissues, quieting the microscopic fires of the day's stress. Notice how the skin on your arms and face feels in this quiet moment. Your skin is not a solid wall, but a porous, living shield. In the world of pharmacology, there is a concept called the 500 Dalton rule, which states that any molecule smaller than 500 Daltons can be absorbed through the skin's stratum corneum. Since almost all essential oil components are well under 300 Daltons, they can permeate the skin with ease. Think of your skin as a dry sponge resting on a damp surface. The molecules are drawn in through the hair follicles and sweat glands, eventually reaching the dermis, where they are picked up by the tiny capillaries of the lymphatic system. What is happening now is a demonstration of lipophilicity. Essential oils are lipid-loving, meaning they dissolve easily in fats and oils, but not in water. And this is a crucial scientific detail, because your brain is the fattiest organ in your body, consisting of nearly 60% fat. This lipophilic nature allows aromatic molecules to cross the blood-brain barrier, a highly selective semi-permeable border that protects the brain from most foreign substances. Molecules like the sesquiterpenes, found in frankincense, Boswellia carteri, are particularly adept at this. Sesquiterpenes are a class of terpenes that contain 15 carbon atoms and 24 hydrogen atoms. Their unique structure allows them to increase the levels of oxygen in the vicinity of the pineal and pituitary glands, fostering a sense of deep, cosmic clarity and emotional stability. You might wonder about the precision of these oils. In a professional setting, the purity of an oil is verified through a process called gas chromatography, mass spectrometry, or GCMS. During this test, the oil is vaporized and pushed through a long coiled tube. Different molecules travel through the tube at different speeds based on their size and weight, a measurement known as retention time. This allows scientists to identify every single one of the hundreds of chemical components in a single drop of oil. It is a mathematical proof of nature's complexity. A single drop of bergamot oil, Citrus bergamia, for example, contains a precise ratio of limonene, linallyl acetate, and linalool that work in synergy. This synergy means the combined effect of the whole oil is greater than the sum of its individual parts, a biological harmony that reflects the interconnectedness of all things in the universe. Consider the cooling effect of peppermint, mentha times piperita. This oil is rich in menthol, often containing between 30% and 55% of this specific monoterpenol. Menthol does not actually change the temperature of your skin. Rather, it binds to the TRPM8 receptors, which are sensory neurons that detect cold. This is a beautiful example of molecular mimicry. The peppermint molecule is shaped in such a way that it tricks the receptor into sending a cold signal to the brain. This triggers a localized increase in blood flow and a relaxation of the smooth muscles. In clinical trials, peppermint oil has been shown to reduce the tension of muscle fibers by blocking calcium channels, which are the electrical gateways that tell a muscle to contract. When those channels are blocked, the muscle has no choice but to let go and soften. At this very moment, your heart rate may be subtly shifting. Research into heart rate variability, or HRV, has shown that inhaling citrus oils can increase the time interval between heartbeats. A higher HRV is a scientific marker of a healthy, resilient nervous system that is currently in a state of rest and digest. While the stars above move in their long, slow orbits, your heart is performing its own rhythmic dance, influenced by the invisible chemistry of the fruits and flowers of the earth. Even the physical properties of the oils are grounded in the laws of the cosmos. Most essential oils have a specific gravity of less than 1.0, meaning they are lighter than water. This is why, in a vessel of water, the oil will always rise to the top, seeking the light. And they also possess a refractive index, a measurement of how much they bend light as it passes through them. For instance, lemon oil typically has a refractive index between 1.472 and 1.475 at 20 degrees Celsius. This suggests that these oils are not just chemical messengers, but also optical ones, interacting with the very light that fueled the plant's growth through photosynthesis. As you remain suspended in this weightless state of relaxation, think of the flashpoint of an oil, the temperature at which it becomes volatile enough to ignite. Many citrus oils have a low flashpoint of around 110 degrees Fahrenheit, making them eager to leap into the air. In contrast, heavier oils like vetiver, Vetiveria zizanioides, have a much higher flash point and a thick, viscous consistency. Vetiver is derived from the complex root system of a grass that grows deep into the earth, sometimes reaching depths of 10 feet. Its oil is heavy with cousimol and isovetiveranol, molecules that act as anchors for the senses. If citrus is the flight of a bird, vetiver is the stillness of the mountain. The universe is a vast machine of cause and effect, and your body is a perfectly tuned instrument within it. The molecules of the plants are the notes, and the air is the medium through which the music travels. There is no effort required on your part. The physics of diffusion, the biology of the alveolar capillary membrane, and the chemistry of the blood-brain barrier are all working in silent, perfect coordination. You are a part of this elegant system, a living witness to the slow, beautiful clockwork of the natural world. Breathe in the science, breathe out the tension, and let the molecular stars of the botanical kingdom guide you toward the stillness of the night. Reflect on the invisible architecture that surrounds you, a molecular quilt woven from the very history of the earth and the life cycles of the botanical world. As you rest in this quietude, you are not merely a passive observer of scent. You are an active participant in a biological dialogue that has long-term implications for the structure of your own mind. Scientists have discovered that our relationship with aromatic molecules is not a series of fleeting moments, but a catalyst for neuroplasticity. For example, the research published in the journal Frontiers in Molecular Neuroscience indicates that consistent olfactory stimulation can increase the volume of the olfactory bulb, the brain's primary scent processing center, by as much as 10 to 15% over time. This suggests that the simple act of breathing in the essence of the world physically expands the capacity of your brain to perceive it. Imagine the way a weaver works at a loom, crossing threads to create a durable fabric. In the quiet theater of your nervous system, scent molecules act as the shuttle, weaving together your internal state with the external environment. This process is governed by the 24-hour cycle of the sun, known as your circadian rhythm. In 2017, the Nobel Prize in Physiology was awarded for the discovery of the molecular mechanisms that control this internal clock. Located in a cluster of cells called the suprachiasmatic nucleus, or SCN. Certain plants, particularly lavandula and gustifolia, have been found to assist in synchronizing these rhythms. By interacting with the SCN, lavender helps regulate the timed release of melatonin, the hormone that signals to every cell in your body that the rotation of the Earth has turned your hemisphere away from the sun. Under the lens of modern biology, we see that the reach of aromatherapy extends far beyond the nose. Think of the sandalwood tree, which must grow for decades to produce its precious heartwood. In a groundbreaking study from 2014 at Ruhr University Bochum, researchers found that human skin cells, known as keratinocytes, actually possess olfactory receptors of their own. Specifically, the receptor OR2AT4 smells the sandalwood molecule, synthetic or natural. When this receptor is activated, it triggers a calcium-dependent signaling pathway that promotes cell regeneration and faster wound healing. This means that as you lie there, your skin is quite literally listening to the chemical signals in the air, using them to repair and maintain the protective barrier of your body. The data suggests that these connections are deeply personal and rooted in our earliest years. Unlike memories triggered by sight or sound, which are often processed later in childhood, odor-evoked memories, known as Proustian memories, are typically formed during the first decade of your life, between the ages of 1 and 10. This is because the olfactory system is one of the first to fully develop in the womb. When you encounter the scent of a specific resin or floral oil tonight, you might find yourself transported back to a sense of safety you haven't consciously thought of in years. This is the hippocampus at work, the brain's librarian, which stores these scent memory pairings in a highly durable format that resists the erosion of time. At this very moment, your body is managing the concentrations of these molecules with mathematical precision. Consider the concept of the half-life, the time it takes for a substance's concentration in your body to be reduced by exactly 50%. The molecule linalool, a primary component in many calming oils, has a half-life of approximately 45 minutes in the human bloodstream. This means that as you descend into rest, the molecules are gradually and gracefully metabolized by your liver and cleared from your system, ensuring that their influence is gentle and non-accumulative. It is a slow, natural fade-out, much like the light of a distant star, eventually dimming as it moves beyond the horizon. Science tells us that the bigger picture of our health is often found in the subtle fluctuations of our stress hormones. In 2014, a study involving Salvia sclarea, or clary sage, demonstrated that inhalation of the oil led to a 5% reduction in cortisol levels in the blood. While 5% may seem small, in the delicate balance of the endocrine system, it is enough to shift the body from a state of alert to a state of profound peace. Think of cortisol as a high-pitched frequency that has been playing in the background of your day. The clary sage acts as a low-pass filter, removing the noise and allowing the deeper, calmer tones of your biology to emerge. Notice how your breathing has become a rhythmic cycle, a mirror of the oscillations found throughout the cosmos. Within each breath, you are taking in roughly 10 to the power of 19 molecules of air. That is, a 1 followed by 19 zeros. Among these are the terpenes of the plants, such as the benzyl acetate found in jasmine, Jasminum officinale. A study conducted at the Ruhr University in Bochum showed that this molecule is just as effective at stimulating GABA receptors as many pharmaceutical sedatives, but without the heavy side effects. It provides a weightless feeling, as if the gravity of your worries has been slightly dialed back, allowing you to float in the comforting void of your own relaxation. In the long-term perspective of your life, these aromatic interventions act as anchors. The term aromatology was coined in 1982 by the Olfactory Research Fund to describe the scientific study of the relationship between psychology and fragrance. Since then, we have learned that scents like rose oil, Rosa damascena, can produce a 40% decrease in sympathetic nervous system activity, as measured by skin conductance tests. The sympathetic nervous system is your fight or flight engine. By reducing its activity by nearly half, the rose molecules are essentially giving your body permission to retire from the day's battles and enter a period of deep, restorative maintenance. What is happening now is an exploration of the synergistic beauty of nature. A single drop of an essential oil can contain between 200 and 500 different chemical constituents. This complexity is vital because it prevents the body from developing a tolerance, a common issue with simplified synthetic compounds. Think of it as a complex orchestral piece rather than a single repeating note. Your receptors are continually engaged by a shifting landscape of molecules, keeping the sensory experience fresh and effective. This is why the scent of a real forest or a real garden feels so much more three-dimensional than a laboratory imitation. Consider the physical density of the tools we use in this science. Tea tree oil, Melaleuca alternifolia, for instance, has a very specific density of 0.885 to 0.906 grams per cubic centimeter. This density dictates how the oil interacts with the moisture in your breath and the oils on your skin. These measurements are not arbitrary. They are the result of the plant's evolution in the specific climate of its origin. The plant produced these molecules to survive, and now those same survival tools are providing you with the means to thrive and rest. In the quiet theater of the night, the wood wide web also plays a role. While we think of aromatherapy as something we do for ourselves, in the wild, these volatile organic compounds are the vocabulary of a vast communication network. Trees use these scents to warn their neighbors of drought or pests. When you use these oils, you are tapping into a global conversation that has been happening for millions of years. You are integrating yourself into the planetary web of information, a connection that reminds you that you are never truly isolated. You are a biological entity in a chemical world, supported by the wisdom of the flora. In 2013, a study on ylang ylang, Cananga odorata, found that it could reduce systolic blood pressure from an average of 130 millimeters of mercury down to 120 millimeters of mercury in just 20 minutes of inhalation. This is a measurable physical change in the pressure of the blood against your arterial walls. As you feel the pulse in your wrists or neck, imagine those walls relaxing, the vessels widening, and the river of your circulation slowing to a peaceful, steady flow. The molecules of the ylang ylang flower, harvested from the tropical branches of the Indo-Pacific, are now part of the internal physics of your heart. Underpinning all of this is the sheer diversity of the molecular world. Scientists have identified over 30,000 different terpenes in the plant kingdom, each with a unique shape and a unique purpose. It is a vast library of solutions for almost every state of being. Whether it is the sedative isovaleric acid in valerian root or the mood-lifting limonene in a lemon, there is a molecule shaped precisely for the lock in your brain. As you move closer to the boundary of sleep, realize that your sense of smell is the only sense that does not sleep. Even while you are unconscious, your olfactory system remains vigilant, processing the air, though the brain chooses to ignore most of the signals to allow for rest. But the therapeutic effects continue. The sandalwood still talks to your skin. The lavender still balances your SCN. The jasmine still whispers to your GABA receptors. You are being cared for by the chemistry of the earth, even as you let go of your conscious thoughts. The larger picture of aromatherapy is one of profound harmony. It is a bridge between the macroscopic world of forests and seasons and the microscopic world of neurons and receptors. It is a reminder that the universe provides exactly what is needed for the rhythm of life to continue. The same laws of gravity that hold the planets in their orbits are the laws that allow a scent molecule to drift into your awareness. You are safe in the clockwork. You are a part of the tapestry. Every breath is a confirmation of your place in this elegant, scented universe, where the science of life is the most beautiful story ever told. Deep within the microscopic world of the botanical kingdom, the colors of these aromatic essences reveal a hidden spectrum of light and energy that interacts with your very biology. Consider the striking ink-like indigo of German chamomile oil. In this deep blue does not exist within the white petals or the yellow center of the living flower. It is synthesized during the steam distillation process when the precursor matricin is heated and transformed into chamazoline. Scientists discovered that chamazoline specifically absorbs light in the 600 to 650 nanometer range of the electromagnetic spectrum, which corresponds to the orange and red wavelengths. By absorbing these warmer colors, the molecule reflects back the cooling blue we see, a visual representation of the oil's profound anti-inflammatory properties. Picture this deep, cool blue light bathing your senses, acting as a chromatic signal for your nervous system to decelerate. Notice how the texture and weight of different scents influence your perception of the room's atmosphere. And this is a result of kinematic viscosity, a measure of a fluid's internal resistance to flow. While a citrus oil like sweet orange, Citrus sinensis, is thin and moves quickly, a base note oil like vetiver, Vetiveria zizanioids, is incredibly thick, possessing a viscosity that is hundreds of times greater. If you were to watch a drop of vetiver fall from a pipette, it would move with the slow, deliberate grace of a cooling lava flow. This thickness is due to its high concentration of sesquiterpenols, large molecules with 15 carbon atoms and 26 hydrogen atoms. These heavy compounds evaporate slowly, creating a persistent, grounding presence in the air. At this moment, imagine the air around you becoming slightly more substantial, as if you are wrapped in a weighted blanket of molecules that are too heavy to be hurried. What's happening now involves the very temperature of your breath and its effect on molecular volatility. Scientists discovered that the boiling points of essential oil constituents vary wildly. For instance, alpha-pinene, the refreshing scent of the forest, has a boiling point of approximately 155 to 156 degrees Celsius. However, because these molecules have a high vapor pressure even at room temperature, they are constantly leaping into the gas phase. This phase transition requires energy, which is why some scents feel physically cool. When you inhale peppermint, the menthol, which has a melting point of exactly 42 degrees Celsius, interacts with the moisture in your nose to create a subtle endothermic reaction. This is the science behind the breath of fresh air sensation, a literal cooling of the tissues as the molecules move from a liquid state into the vast open space of your lungs. At this very moment, your nose is functioning as a biological tuning fork. A fascinating theory in olfaction, championed by biophysicist Luca Turin, suggests that we don't just smell the shape of a molecule, but we hear its vibration. This is known as the vibrational theory of olfaction. It proposes that when a molecule enters an olfactory receptor, electrons tunnel through it, sensing the specific frequencies at which the chemical bonds are vibrating. These vibrations are measured in wave numbers, or inverse centimeters. For example, the carbon-hydrogen bond vibrates at a frequency of approximately 3,000 wave numbers. Think of every scent molecule as a tiny invisible instrument playing a specific chord. As you breathe, you are listening to a silent symphony of molecular music, each note vibrating at a frequency that your brain interprets as a specific emotion or memory. Scientists discovered that the human sensitivity to certain earthy scents is among the most acute in the entire animal kingdom. Consider the molecule geosmin, the scent of damp earth after a rainstorm. The human nose can detect geosmin at a concentration of 5 parts per trillion. To visualize this incredible sensitivity, imagine a single drop of geosmin dissolved in the equivalent of 200 Olympic-sized swimming pools. You would still be able to perceive its presence. This sensitivity evolved because our ancestors needed to find water and fertile soil. Tonight, that same evolutionary drive allows a microscopic amount of an earthy oil like patchouli, Pogostemon cablin, to trigger a deep ancestral sense of security and belonging. Picture this. The plant itself stores these precious molecules in specialized structures called glandular trichomes. These are microscopic balloon-like sacs located on the surface of the leaves or petals, often measuring only 50 to 100 micrometers in diameter. To put that in perspective, you could fit several of these sacs on the tip of a sewing needle. When you brush against a lavender leaf or a sprig of rosemary, you are physically rupturing these tiny containers, releasing the volatile contents into the air at a velocity governed by the internal turgor pressure of the plant cells. This is a delicate mechanical event that happens millions of times, a silent explosion of fragrance that fills the void around you. Notice how the scent of Eucalyptus globulus, seems to penetrate deeper than others. This is due to its high concentration of 1,8 cineol, which typically makes up 70 to 85% of the oil. Beyond its interaction with the olfactory bulb, cineol is one of the few molecules that can stimulate the trigeminal nerve directly. This nerve is responsible for the chemisthesis, the physical sensations of chemistry, such as the tingle of carbonation or the sting of a chili pepper. In the case of eucalyptus, it produces a sensation of openness in the sinuses. It physically alters the sensory perception of the volume of air you are moving, making each breath feel more spacious and effortless, as if the very dimensions of your chest are expanding into the quiet room. Deep within the chemistry of wintergreen, Gaultheria procumbens, we find one of nature's most focused expressions. This oil consists of over 98% methyl salicylate, a natural precursor to aspirin. It is a rare example of a plant producing a nearly pure chemical compound. Methyl salicylate has a specific gravity of 1.18, meaning it is actually heavier than water, one of the few essential oils that will sink rather than float. As you rest, imagine the heavy, sweet warmth of this molecule sinking into your muscles, its high density providing a sense of physical permanence and relief. Consider the optical properties of these oils, specifically their refractive index. As light passes through a drop of rose oil, it is bent at an angle measured between 1.457 and 1.467. And this refractive index is a signature of the oil's purity and molecular density. It suggests that these liquids are more than just scent. They are a medium that alters the path of light itself. If you could see the air in your room, it would be filled with these tiny prisms, each one slightly refracting the moonlight or the dim glow of the evening, creating an invisible shimmering fog of botanical information. What's happening now is an interaction with the specific rotation of the molecules. Many essential oils are optically active, meaning they rotate the plane of polarized light to the left or right. For instance, lemon oil has a specific rotation of plus 57 to plus 70 degrees, a right-handed twist that contributes to its uplifting and bright character. In contrast, peppermint oil rotates light to the left, between minus 18 and minus 32 degrees. And this chirality is not just a mathematical curiosity. Your receptors are shaped to fit these specific twists. It is as if your brain is a puzzle, and the molecules are the pieces that must be oriented exactly right to unlock the feeling of peace. Notice how the surface tension of the oils allows them to spread. Essential oils have a much lower surface tension than water, typically around 20 to 30 millinewtons per meter, compared to water's 72. This low surface tension is what allows them to coat the lining of your lungs so efficiently, spreading out into a monomolecular layer that maximizes absorption. This is why a single drop of oil can have such a profound effect. It has the physics to cover a vast biological area, ensuring that no part of your respiratory forest is left untouched by its influence. Scientists discovered that even the age of the plant material changes the molecular song. In patchouli, The primary constituent patchoulol actually increases in concentration as the leaves are dried and aged. This process changes the molecular weight and the scent profile, moving it from a sharp green note to a deep, resonant woodiness. This is a reminder of the slow dance of time. Even after the plant has been harvested, the chemistry continues to mature, seeking a more stable and peaceful state. It is a biological quest for equilibrium that mirrors your own descent into rest. As you breathe, think of the molecular weight of a monoterpene, which is approximately 136.23 grams per mole. These are the light flyers of the aromatherapy world. Then, consider the sesquiterpenes, which are heavier at around 204.35 grams per mole, and you are currently experiencing a multi-layered arrival of these molecules. First, the light, fast-moving monoterpenes that clear the mind, followed by the slow, heavy sesquiterpenes that anchor the body. It is a perfectly timed sequence, a chemical transition from the activity of the day to the stillness of the night. The temperature of your skin, usually around 33 to 35 degrees Celsius, acts as a heat lamp for these molecules. This warmth provides the kinetic energy necessary for the molecules to break free from the surface of your skin and enter the airspace around your face. You are essentially a living diffuser, using your own metabolic warmth to fuel the science of your own relaxation. There is a beautiful reciprocity in this. Your body provides the energy, and the plant molecules provide the peace. In this quiet, a microscopic landscape, there is no room for haste. The laws of physics, diffusion, refraction, and vibration, are all operating with a silent, mathematical certainty. The molecules are moving exactly where they need to go, fitting into their receptors with the precision of a key in a lock, and vibrating at the frequencies of tranquility. You are the observer of this elegant system, a witness to the profound science that connects the life of a flower to the life of your own mind. Everything is in balance. The air is rich, the chemistry is kind, and the universe is performing its slow, beautiful clockwork just for you. The long journey of the aromatic molecule, from the heartwood of a tree or the petal of a flower, now reaches its final, quiet destination within your biology. Insorin. As the rotation of the earth carries you further into the shadow of the night, the external world begins to recede, leaving you in a state of suspended observation. What happens next is a highly coordinated, step-by-step transition from the alertness of the day to the profound stillness of the comforting void. This process is governed by the laws of biochemistry and the slow, rhythmic clockwork of your internal systems. Consider the gradual unfolding of signal transduction that began with your last breath. When those volatile organic compounds bound to your olfactory receptors, they didn't just sit there. They activated a sophisticated relay race within your cells. Each receptor is a G-protein coupled receptor, or GPCR. Scientists discovered that roughly 3% of the entire human genome is dedicated solely to the instructions for building these receptors. This highlights just how fundamental our sense of smell is to our survival and our peace. Once the molecule clicks into the GPCR, it triggers a cascade involving cyclic adenosine monophosphate, a messenger molecule that tells the neuron to fire. This electrical signal travels at a precise speed along the olfactory nerve, reaching the brain's emotional centers in approximately 110 milliseconds. As you remain motionless, notice the shift in your thermoregulation. For sleep to be truly restorative, your core body temperature must drop by approximately 1 to 2 degrees Celsius. This cooling is managed by the hypothalamus, specifically the suprachiasmatic nucleus, which acts as the master conductor of your circadian rhythms. At this very moment, the aromatic molecules of oils like sandalwood or bergamot are assisting in this cooling process by encouraging vasodilation, the widening of blood vessels near the surface of your skin. As these vessels expand, heat is radiated away from your body and into the surrounding air, allowing your internal organs to reach the lower temperature required for deep Stage 3 NREM sleep. What is occurring now is the buildup of adenosine, a nucleoside that creates what scientists call sleep pressure. Throughout the day, as your cells use energy, adenosine levels rise, eventually binding to receptors that tell your brain it is time to rest. When you use aromatherapy, molecules like valerianic acid from valerian root or linalool from lavender act as modulators, and they don't just mimic sleep. They physically enhance the binding of GABA, an inhibitory neurotransmitter, to its receptors. Think of GABA as the nervous system's internal braking system. By increasing the efficiency of these brakes, the aromatic chemistry allows the electrical activity of your brain to slow down from the fast beta waves of wakefulness to the long rolling delta waves of deep sleep, which oscillate at a frequency of just 0.5 to 4 Hz. In this state of deepening repose, your brain begins a process discovered only recently, in 2012, by researcher Maiken Nedergaard: the activation of the glymphatic system. While the rest of your body uses the lymphatic system to clear debris, the brain has its own specialized method. During sleep, the space between your brain cells increases by as much as 60%, allowing cerebrospinal fluid to flow through and effectively perform the task of clearing metabolic waste. Picture this as a slow, rhythmic tide moving through the architecture of your mind, clearing away the chemical remnants of the day's thoughts. This clearing of cellular debris is most efficient when the body is in a state of total parasympathetic dominance, a state that the molecules of frankincense and vetiver help to sustain through their interaction with the limbic system. At this very moment, consider the atoms that make up both you and the oils you breathe. The carbon, oxygen, and nitrogen in a molecule of linalool were not created on Earth. They were forged in the high-pressure furnaces of ancient stars billions of years ago. Through the process of stellar nucleosynthesis, stars converted hydrogen and helium into the heavier elements that now form your bones, your neurons, and the very scent of the flowers. You are, in the most literal scientific sense, made of stardust. The fact that your brain can perceive the essence of a plant is a testament to the fact that you and the plant share the same cosmic origin. You are a way for the universe to experience its own chemistry. As you move closer to the threshold of the void, your breathing enters a highly predictable rhythmic cycle. During sleep, the rate of carbon dioxide exhalation changes, and your heart rate variability increases, a sign of deep physiological resilience. You are currently transitioning through your first 90-minute sleep cycle. In this time, your brain will move through light sleep, deep sleep, and eventually REM, where your memories are consolidated. The sesquiterpenes you inhaled earlier, with their large molecular weight and ability to cross the blood-brain barrier, are still present in your system, providing a steady chemical foundation for this journey. Because they have a longer half-life than the lighter monoterpenes, their grounding effect persists long after the initial scent has faded. Notice how the weight of your body seems to merge with the surface beneath you. This is the result of muscle atonia, a natural paralysis that prevents you from acting out your dreams. It is a safety mechanism of the brainstem, ensuring that while your mind explores the microscopic and macroscopic wonders of the cosmos, your physical form remains safe and still. You are floating in a sea of gravity, held in place by the same force that keeps the moon in its 27-day orbit around our planet. Gravity is the silent, constant embrace of the Earth, a physical law that never falters. Deep within your cells, over 100,000 biochemical reactions are occurring every second, even in this state of rest. Your DNA is being repaired, your proteins are being synthesized, and your energy stores are being replenished. This is the internal warmth of sleep, not a heat that burns, but a glow of biological maintenance. The aromatherapy molecules have done their job. They have acted as the catalysts, the keys that unlock the doors to this restorative chamber. Now, the science of sleep takes over completely. At this very moment, imagine the molecules of scent becoming part of your own structure. As they are metabolized, their atoms are recycled into new forms, continuing the endless loop of matter and energy. Nothing is ever lost in the universe. It only changes shape. You are a temporary gathering of stardust, currently arranged in the beautiful, complex form of a human being who is ready for rest. As we conclude this journey through the science of scent and the physics of peace, carry these affirmations with you into the silence. My body is a masterpiece of biological precision, and tonight it is at rest. The atoms within me are old, stable, and part of the enduring fabric of the cosmos. My breath is a rhythmic bridge between the earth and my mind. I am safe within the laws of physics and the steady pull of gravity. The chemistry of the botanical world has prepared my mind for stillness. My brain is now engaging in the deep work of restoration and clarity. I am clearing away the remnants of the day to make room for tomorrow's light. The void of sleep is not a darkness to be feared, but a space of profound healing. I am a participant in the slow, beautiful clockwork of the universe. Every cell in my body is vibrating at the frequency of peace. The molecules of the plants are my silent companions in this rest. I am weightless, supported by the ancient elements that formed the stars. My heart beats in harmony with the slow rotation of the earth. The journey of the day is complete, and the laboratory of my mind is quiet. I am part of the earth, part of the stars, and part of the infinite silence. The molecules have settled. The electrical signals have slowed. The glymphatic tide is rising to refresh your mind, and there is nothing left to do but exist in this perfect scientific state of repose. You are home in the universe. You are safe in the night. Good night.